Good afternoon, everyone. I am Grace Gallardo from BSN Math 3B, and today we are going to discuss the Chapter 8.4 of Advanced Statistics, which is all about the z-test for a proportion. First, let us define what is a z-test. A z-test is a statistical test to determine whether two population means are different when variances are known and the sample size is large. A z-test is a hypothesis test in which the z-statistics follows a normal distribution. So what is the difference between z-test and t-test? We knew that they are almost closely related, but t-tests are best performed when an experiment has a small sample size. Z-test assumes that the standard deviation is known, while on the other hand t-test assumes that the standard deviation is unknown. Now we are going to do hypothesis testing situations that involve proportions. Recall from Chapter 7 that a proportion is the same as a percentage of the population. A hypothesis test involving a population proportion can be considered as a binomial experiment when there are only two outcomes and the probability of success does not change from trial to trial. We knew that mean is equal to NP and the standard deviation is equal to the square root of NPQ for the binomial distribution. Since a normal distribution can be used to approximate the binomial distribution when NP is greater than or equal than 5 and NQ is greater than or equal than 5, the standard normal distribution can be used to test hypotheses for proportions. Now this is the formula for the z-test for proportions. Z is equal to p hat minus p over the square root of pq over n, where p hat is equal to x over n, or the sample proportion. P is the population proportion, and n is the sample size. The formula is derived from the normal approximation to the binomial and follows the general formula. Test value is equal to observed value minus expected value over the standard error. We obtain p hat from the sample, which is the observed value. P is the expected value, or the hypothesized population proportion, and the square root of pq over n is the standard error. This formula can be derived from the formula z is equal to n minus mean over standard deviation by substituting mean is equal to np and standard deviation is equal to the square root of npq, and then dividing both numerator and denominator by n. Table E is used to find the critical values and p-values. Now we are going to do some example exercises from this chapter, but we have to remember two things. Sometimes p hat is necessary to find, and sometimes p hat is given in the exercise.